All right, here we have a shopping mall that has 3 automated teller machines. And because the machines receive heavy use, they sometimes stop working and need to be repaired. So we're going to let the random variable x represent the number of ATMs that are working when the mall opens on a randomly selected day. So this table shows the probability distribution of x. Right, part A, what's the probability that at least one ATM is working when the mall opens? Okay, so for there to be at least one ATM working, we don't need to know which one. It could be like the first one, second one, third one. We don't know. But you want to just think of it as what's the probability that none of them will work? The probability that no ATMs will work is 0.15. So the probability that at least one will work, so the probability that we can say the probability that x is greater than or equal to 1 is equal to 1 minus the probability that x is equal to 0. So 1 minus 0.15 or 0.85. What's the expected value of the number of ATMs that are working when the mall opens? Okay, expected value is, again, just think of it as like the mean. But again, when we're dealing with random variables, not each value doesn't have the same probability. And this is given in your formula sheet, so you don't have to worry about not memorizing it. I've been doing this, for a very long time, for years, so I know it off the top of my head. So the expected value, let's do it actually over here. E of x will be the probability that x equals 0 times 0, so 0 times the probability that x is 0, plus 1 times the probability that x is 1, plus 2 times the probability that x is 2. Let me put that in. Plus 3 times the probability that x is 3. So we just did the algebra here. This doesn't matter because that's going to be 0. Probability x is 1 is going to be 0.21, so 1 times 0.21, so just 0.21, plus 2 times 0.4, plus 3 times 0.24. And again, you can use your calculator on the entire exam, so 0.21 plus 0.8 plus 3 times 0.24, so 1.73. Right, part C. What's the probability that all 3 ATMs are working? Given, now let's pay attention, given that at least one ATM is working. So the probability that all 3 of them are working, given that at least one is working. So we're going to use our conditional probability formula. So we're going to use the probability that A given B, that'll be equal to the probability of A and B over the probability of B. And again, this formula is given on your formula sheet. It's more about you knowing how to apply it. So okay, so we have to determine what we want A and what we want B to represent. So we're gonna have A be the probability, or we're gonna have A represent that all 3 ATMs are working. So let's write that. And we'll have B be like what we're given, that at least one ATM works. So the probability of A given B will be equal to the probability of A and B over the probability of B. So the probability that, let's do probability of B first. The probability that at least one ATM works, we already found that in part A, so that'll be 0.85. Now the probability of A and B, so the probability that all 3 ATMs work, given that at least one works. So you want to just think of this as as basically all 3 of them working. So then that will just be equal to 0.24. It's probability of all 3 of them working is 0.24. And so then our answer will be 0.24 divided by 0.85. That'll be a 0.282. All right, part D. Given that at least one ATM is working when the mall opens, would the expected value of the number of ATMs that are working be less than or equal to or greater than the expected value from part B? So would the expected value be greater than 1.73 if we're given that at least one ATM is working? Okay, so let's think about this. If we're given that at least one ATM is working, then this essentially takes away the possibility of there being no ATMs working. So like your sample space just consists of 1, 2, and 3. However, like these probabilities are going to change because the probabilities of these 3 remaining values have to add up to 1. So with this one gone, this, and this will increase. They're gonna increase proportionally. But again, just think of this as think of something where if you have 10 people and you're measuring you're trying to figure out the average height of 10 people, and it's it's maybe 5'3", let's say. If you were to take away the shortest person, what's going to happen to the average height? Well, the average height is going to go up because you're taking away the smallest value. So it's just think of that. That's the intuition. It's not actually asking for the value of it. So it's looking for you to explain it. Make sure you write an explanation thoroughly. But I'm actually going to go through the mathematical work because it's really actually going to help you understand this better and see how this works and looks when you calculate it. Okay, so let's look at the expected value. We're looking for the expected value of number of ATMs given that this is gone now, that 0 is gone. So it's going to be 1, again, times the probability that x is 1, plus 2 times the probability that x is 2, plus 3 times the probability that x is 3. So we have to figure out what the probability of x is 1, x is 2, and x is 3 are. Now, so let's break this one down. The probability that x is 1, given that one ATM works, essentially means that none of the other ones are going to work. So you're basically just going to have this value .21 over 0.85. So think of these as what's going on here. These are conditional probabilities. Probability that x is 1. The condition that that 1 at least works, so we're going to be dividing this by 0.85. And then we find the top is what's the probability that x is 1, just in general, 0.21. Again, for now the conditional probability that x is 2, given that 1 is working. So we're going to divide by that 0.85. And then what's the probability that x is 2? 0.4 in our table. So 0.4. And the probability x is 3. Again, we're going to divide by the 0.85. And what we have is 0.24 for x being 3. Just 0.24. So you're basically going to have your expected value being 1 times this, plus 2 times this, plus 3 times that. So let's see what we get. And you're going to get an expected value of about 2.035. So again, when they're asking you to explain it, you could say it in words. You don't actually have to do this. You would say again that since we take away the probability or the possibility there being no ATMs working, all of these are going to increase their probabilities proportionally. So they're all going to be divided by that 0.85, which is what we're doing there. All right, and that's it for that.